So, good day again, class. It's Sir Gerald. As I mentioned last time on our discussion regarding Chem 21, organic chemistry during our discussion on functional groups, I have mentioned that I have mentioned that for each of the functional group, we will be going through the structure, the nomenclature, the physical properties, and reactions. So, since we will be talking about reactions of organic compounds, so let's first dive into some of the reaction mechanisms of some organic compounds. So, for some beginners, dito tayo nagkakaroon ng problema sa pag-intindi ng tinatawag nating reaction mechanisms, lalong-lalo na kung medyo hindi gano'n kaganda yung foundations natin sa chemistry per se. So, hopefully, during your Chem Zero times, may mga na-observe tayo dong kaunting reaction mechanisms para at least mas makakasabay tayo dito. So, getting into that, so we actually have four major organic reaction mechanisms. We have the addition reaction, we have the elimination reaction, substitution reaction, and rearrangement. And meron tayo lang mga ilang idadagdag when it comes to this reaction mechanisms, which we will be also describing oxidation and reduction, which may fall into one of those four other categories. Because when we talk about oxidation and reduction, it may be an addition reaction, it may be elimination reaction, substitution reaction, or rearrangement. It depends. So it falls under a special category of organic reactions. So when we talk about organic reactions, syempre, hindi natin pwedeng ma-miss out yung mga tinatawag nating reagents and substrates. So, by reagents and substrate, uh, when kapag sinabi nating substrate, ito actually yung these are the reactants, which are not actually, ito yung nag-undergo ng change. And the reagent is what we call which is added to our substrate. Basically, in organic reaction, when we talk about the substrate, mainly these are our organic compounds. Okay, and this reagent, it may be an organic compound or any other inorganic compound, wherein this reagent introduce the change to our organic compounds, therefore producing what we call the products. Okay? So, by definition, substrate is the reactant that is acted upon or attacked by reagent. It is also a molecule which contains the carbon atoms to which carbon bonds are broken and made. So, when we are talking about organic reaction, we will be looking into these substrates, and these substrates, with the presence of their functional groups, uh, dun mag-undergo or dun mag-act yung tinatawag nating changes, therefore producing our product. So, the classification of organic reactions into addition, elimination, and substitution and rearrangement is based on the changes that occur in the bonding to carbon atoms in the substrate. Meaning to say, we can characterize or we can classify each of the reactions based on the changes that happened on our substrate. So let's go into the uh, first reaction mechanism, which is our or so. But first, here are the list of the organic reactions. Like I said earlier, we have the addition, reaction, elimination reaction, substitution reaction, rearrangement, oxidation, and reduction. And as I said earlier, these two may fall under rearrangement, substitution, elimination, or addition reaction. So in any case, here is the first uh, organic reaction, which is the addition reaction. So addition reaction is caused by the increase of number of atoms or group of atoms attached to carbons in the substrate. Occasionally or most of the time, addition reaction happens during for organic compounds that have double bond or triple bond. But basically, there is an excess in the number of bonds in the carbons that breaking those bonds introduce the changes to the atoms in which we can add other atoms to that breakage. Basically, if we have here our double bond, one of these bonds may break, causing a lone valence electron in which some other atoms may bond. Therefore, mag-a-add tayo ng panibagong atoms dun sa ating carbon compounds. So one example of this is the reaction of ethane and chlorine gas. So by ethane, let me just change the color of my pen. So by ethane, this uh, for the chemical formula, we have here the CH2 CH2. So, structurally, ang magiging itsura niya ay ganito. So, if we have here our ethane, our double bond, we have here our hydrogen. So, in that, if we introduce chlorine gas to the reaction, say plus we added Cl2. Okay, so if conditions are right, let's say there is a formation of free radical or formation of nucleophiles. Due to that, magkakaroon tayo ng breaking, magbe-break yung isa ron sa mga bonds. Therefore, ang mangyayari, magkakaroon tayo dyan ng C H. We have H here. Hopefully, nakikita niyo pa. And we have here a lone pair. Then, we have here a single bond of carbon to carbon. And we have here our hydrogen and our hydrogen. And we have here our valence electron or free valence electron due to that breakage. Wherein we will also have here cleaving of the bonds between Cl and Cl. Pag break yan, we will have Cl, Cl, and those Cl will bond to this. Therefore, we will be having a carbon compound which will look like this. So we have there our hydrogen, we have here our Cl, we will have here our carbon, we will have here our hydrogen, and our Cl. So for the arrangement of the compounds, don't worry about that because due to the presence of this carbon single bond, the the location or the arrangement of this hydrogen and chlorine may actually interchange. Kumbaga umiikot sila along this bond, so hindi ganun ka-importante yung arrangement. Okay, which we'll be talking more about once we talk about reactions on alkenes, which is one example here is our ethene. Okay, so that is our addition reaction. Basically, in addition reaction, we just add another set of atoms to our carbon compounds. So, carbon compounds plus atoms, other atoms, therefore addition. So our next reaction actually is from if we have addition, syempre meron tayong subtraction or in this case, we mean elimination reaction. So elimination reaction is caused by a decrease in the number of atoms or group of atoms in the substrate. So meaning substrate, there is less or a decrease in number of atoms. If substrate, that we mean there are carbon compounds. Okay? So in that, double bond carbon to carbon formation yung nagiging product natin. And is usually caused by the formation of hydrogen ions due to heat change. Meaning to say, if we are to introduce hydrogen ions and heat, we will form what we call here double bonding. So, for example, we have here an alcohol. So we have here our hydrogen and our OH in our carbon compound, and we introduced hydrogen ions and heat. The presence of hydrogen ions and heat introduce the breaking of the bonds between the hydroxide and our carbon and our hydrogen in our carbon compound. Due to that, we will form here a double bond, that double bond, and water. So that is our elimination reaction. This is just an example. Elimination reaction can also happen to other other functional groups. By other functional groups, it can happen with halides, also with amides, ammonium or amines, and also our sulfides or sulfur and our thiols. Okay, so for an example of that, let's have the simplest example, which is the ethanol. Ethanol. So for ethanol, ethanol is just a two carbon compound with one alcohol functional group. So meaning to say we have here this hydrogen, and if we introduce heat to our ethanol, we will form what we call the ethene. So we have here four hydrogen. So that we have here one, two, three, four hydrogen atoms. So from ethanol, in which we introduce hydrogen ions and heat, we form what we call ethene. So ethene and syempre, okay. So our next reaction mechanism is what we call the substitution reaction. So by substitution reaction, it is just as you heard it, it is substitution, meaning to say an atom or a group of atom in the substrate is replaced by another atom or group of atoms. Basically, palitan lang. So if we have here our hydrogen A, hydrogen atom A, and we have here our atom Q. If we add atom Q to our the substrate, will it can happen that the Q will replace A, therefore forming this. Okay. One example of this is the reaction of methane and bromine, but it only occurs in some certain reaction. I can't remember to be exact. So if we have here our methane, which is CH4, and we add, let's say, bromine, Br2. In some conditions, I can't remember if it is a dark reaction or some. Basically, if bromine atom breaks into two atoms, therefore forming what we call bromine. Let me just draw the Lewis structure of that. So we have here a bromine which has three lone pairs and one valence electron, free valence electron. Same with this. So basically, this bromine will be looking for a nucleus due to the presence of many electrons around it. So basically, this bromine will attack that hydrogen or any of those hydrogen, therefore forming what we call methyl bromide. So which it will look like this. So we have here CH3 and we have here bromine plus we have here the H and also the Br. So we have there our substitution reaction. Okay. So for the last part or the last example of or the last reaction mechanism or major reaction mechanism, we have here the rearrangement. So basically, rearrangement of an atom or group of atoms in a substrate migrates from one atom to another. It is usually caused by a presence of ionic compounds in the substrate. So we have here our ionic compound, which is aluminum trichloride or aluminum chloride. Given that it is ionic, we don't have to mention the numbers of or the number of ions that is attached to the compound. So we have here aluminum chloride. So for the aluminum chloride, due to the presence of aluminum chloride, this group of atom may migrate from that part to another. So that is our rearrangement reaction. So so for our special types of organic reaction mechanisms, we have here our oxidation. So oxidation caused by an increase in the oxygen content or decrease in hydrogen content of a substrate. So for this example, if we have an alcohol meaning because we have here, as you may have remembered from our past discussion, we have here our alkyl group and we have here an OH. So if we have here an alcohol that is catalyzed or there is a presence of what we call here chromic acid, okay, and this presence of this excess oxygen introduce a change in our alcohol, forming what we call a carboxylic acid. So one example of this may be our maybe let's use methanol. So for methanol, we have here CH3OH. If we introduce here our chromic acid, due to the presence of this excess oxygen in our chromic acid, we will introduce oxygen to this methanol. Therefore, we will have here a double bond of O, and we will have here OH and another hydrogen here, therefore forming what we call methanoic acid. As you may see here, there is an increase in oxygen content of the product. So from the original, we only have one oxygen. And for the product, or from the substrate, we only have one oxygen. And for the product, we have two oxygen. And if we count the number of hydrogen, from the original or the substrate, we have three hydrogen that is attached to our carbon atom. And for our product, we only have one hydrogen that is attached to our carbon. Okay? And for the if we have oxidation, we will be remiss if we don't mention what we call reduction. So this is the opposite of oxidation. If the in oxidation we are adding oxygen and reducing hydrogen. For reduction, uh, we actually increase the hydrogen content of our substrate or decrease the oxygen content of our substrate. So, for example, we have here uh, a double bond in carbon. So, as you may have remembered from our discussion, this double bond in oxygen may exist in carboxylic acids, in ketones, and on aldehydes. So, uh, notice that in this general structure or this general formula, due to the presence of nickel and hydrogen, we actually, from the substrate that we have a carbon that is double bonded to an oxygen, our product have a carbon that is attached to a alcohol functional group and a hydrogen. So an example of this may be propanone. So for propanone, or maybe just propaldehyde, we can use actually propaldehyde. So we have there CH3, CH2, and we have CH, and we have there. Okay. So if we introduce our propaldehyde to an excess uh, hydrogen and our metal here, which is nickel, we will actually produce what we call propanol. So by propanol or 1 propanol, we will have there CH3, CH2, CH2, and we will have here our OH. Okay, so that is all for the types of reaction mechanism of our organic compounds. So, here are just the following are just some discussion regarding the mechanisms of the breaking of bonds and the activation energy required for reactions to exist. As you may have remembered earlier, uh, in our elimination reaction, for the elimination reaction to exist, kailangan natin mag-introduce ng tinatawag nating heat or heat change para mag-occur yung reaction. So, bakit nga ba may ganun? So, later, we will be talking about that under what we call reaction energy diagrams. But before that, let's talk about some breaking bonds or covalent bond breaking, or in some cases, it is called our bond cleavage. By bond cleavage, there is cleaving of bond, meaning to say there is a division. So we have actually two types of bond cleavage. We have the homolytic bond cleavage and the heterolytic bond cleavage. From their name itself, homo means one, hetero means different, and we have here lithic, which is actually derived from lysis, or means breaking, cutting, or severing. Or an example of lysis na tinatawag natin is the hydrolysis or the breaking of bonds of using water. Okay? So for homolytic bond cleavage, the bonds breaks into symmetrical ways such that each of the atoms joined by bonds get one electron, resulting in fragments called what we call free radicals. So an example of that is if we have here an atom X, which is bonded to another atom X. If we say that this is a homolytic bond cleavage, we will be having a movement of electrons from our bonds towards our atoms. So, if we are to use that arrows indicating the movement of electrons, so if we are to use an arrow that has a single or a half head like that, we just rewrite that way. So basically, this signifies that there is a movement of one electron. So basically, if we rewrite that on the other side, there is two electrons from the bonds. One of the electrons move to one of the atoms, and the other one moves into the other atom. So meaning to say, we will have here two X atoms, which has one electron from from the bonds. So we call that atom as our odd electron. Or basically, this atom is what we call our free radical. Okay? So, kailan ba nangyayari yung bond cleavage na ganito or yung tinatawag nating homolytic bond cleavage? This can happen in what we call covalent bonds. So, in covalent bonds, almost yung dalawang atoms natin or two of our atoms have the same electronegativities. Meaning to say, the electrons have no tendencies to select one of the electron over the other. Meaning to say, there is no bias regarding the movements of electrons. So, we have here a homolytic, so of the both sides of the bonds get one electron or one odd electron, therefore forming what we call a free radical. So for the heterolytic bond cleavage, in this bond cleavage, the bonds break in such a way that both of electrons remain in one atom. That causes the formation of positive and negative ions. So that can happen when there is some of there is a bias between the two atoms, wherein for, for example, we have here our X atom and Y atom, and if we suppose that Y, not that Y, this Y is more electronegative than our X atom, there is a bias towards the movement of the electrons from our bonds. So meaning to say, we have here a double headed arrow, meaning to say there are two electrons that move from our bonds to Y, meaning to say we will have here a positively charged X due to the missing of one electron and a negatively charged Y. So therefore forming what we call a cation and an ion. Okay. So therefore, due to the breaking of this covalent bonds, we actually have what we call an uh, what we call ionic species or yung tinatawag nating ions. So in that, actually, the formation of covalent bonds can occur through exactly in reverse process. So kapag meron tayong dalawang free radical, and those free radicals almost have no difference in their electronegativity. As you may have remembered, at least hindi greater than 2 or 2 yung kanilang difference between their electronegativities. We will be then forming what we call covalent bonds. So, as you may have remembered, from that homolytic bond cleavage, if we just reverse the reaction, we will be actually forming what we call covalent bonds. So, for heterolytic bond cleavage, medyo hindi ganun yung pangyayari when we talk about this bond cleavage. Basically, hindi mo basta-basta mare-reverse yung reaction. Okay? So, in that, bond cleavage, magkakaroon tayo actually ng magkaibang tinatawag nating reagents. So, uh, there are different types of reagents based on what they do or how they attach to our carbon atoms. So, we actually have three types of reagents. We have here our nucleophilic reagents, or basically nucleus labbing reagent. So we have nucleophiles, and we have electrophiles, or electrophilic reagents, which are basically electron lobbing reagents. And we also have what we call free radical reagents. So, as you may think of, free radical reagents came from what we call our homolytic bond cleavage. Okay? And these two, nucleophiles and electrophiles, exhibit what we call the heterolytic bond cleavage. So that is why we introduce the homolytic bond cleavage and heterolytic bond cleavage due to these types of reagents. So first, let's first identify the first reagent, which is the nucleophilic reagent. So nucleophilic reagents or nucleophiles are actually species that have pairs of electrons that can be used in bond formation. So basically, when we talk about nucleophilic reagents, these are reagents that have a lot of electrons. So due to this abundance of electrons, they are looking for yung sinasabi nga natin dati, opposite attracts. So meaning to say, they are looking for a nucleus or more nucleus, meaning to say, they are seeking for positiveness, some sort. So, basically, some examples of nucleophilic reagents may be our halogens, or one example may be our iodide. Water sometimes behaves as a nucleophile. Also, we can actually also add ammonium and also our hydroxide. So basically, these are some of examples of electron-rich reagents. So one example of what we call an nucleophilic reaction is the reaction or the substitution reaction between uh, methyl chloride and ammonia. So basically, what will happen here is we will first have a heterolytic bond cleavage between our ammonium or N or nitrogen and our hydrogen. Also, same with our methyl and chloride, therefore forming what we call uh, nucleophilic reaction. So in that nucleophilic reaction, what will happen here is we will have cleaving of bonds between this first. So we will have here CHCl3, and we will have here our negatively charged NH2 plus our positively charged hydrogen. The presence of this will have the presence of these ions introduce a change or a reaction or a reaction in our substrate here. So it may happen that our ammonium will attack us our carbon here, therefore cleaving chlorine. So we will have here a CH NH2 plus our chlorine here, which is negatively charged, and our hydrogen, which is positively charged. So, lagyan ko ng arrow ha. So, therefore, forming a product which is CH3NH2 plus our hydrochloric acid, which is HCl. Okay? So, that is one example of our nucleophilic uh, reaction. So, for another type of reagent, we actually have what we call here electrophilic reagent or electron loving reagent. or our electrophiles. So these are a species of electrons that are electron deficient, they are capable of forming new bonds by accepting a pair of electrons. So kung yung ating nucleophiles ay electron rich, when we talk about electrophiles, these are what we call electron poor atoms or group of atoms, meaning molecules. Okay. Some examples of electrophiles may be what we call here hydrogen. We also have our iron 3. We also have our methyl, and we have also have here our hydrogen bromide. Okay. Also, our ferric or iron 3 bromide, and also our aluminum chloride. Alright. So here are some of the electron poor reagents that we have. So for an example of this, it can be a reaction of H2C or our ethene plus our hydrochloric acid. So for this reaction, as you may notice, we actually have here our electron rich na reagent, but basically ano ba yung nagpapa electrophilic reaction dito sa ating ethene and hydrochloric acid? So basically, the product of this will be an ethyl chloride. So basically, this is actually an addition reaction we will have a breaking of this bond. But due to the heterolytic cleavage of HCl, we will actually have here our ethene. Wait a second. We have here our H2CH2, CH2, wherein we will have here our positive hydrogen and our negative chlorine, in which the hydrogen will attack the double bond first. So this is actually what we call an electrophilic attack, meaning to say this reaction is an electrophilic reaction, which will uh, in which we will have a product which is uh, CH2, and we will have here our hydrogen, and we will have here our CH2 and our chlorine. So basically, this is an addition reaction wherein the first attack is actually an electrophile. So this is actually considered as our electrophilic reaction. Okay. So for our last type of reagent, we have here our free radical reagent. So basically, for reagent, free radical reagent comes from what we call homolytic bond cleavage, in which the species have odd numbers of electrons, which they are, in that sense, due to the odd numbered electron, they are very reactive and have the tendency to pair up uh, with single electrons. So one example of this may be the reaction of any aliphatic compounds, wherein for aliphatic compounds, let's say if we have here our CH4, and that CH4 is reacted to chlorine, what can happen here, given that the condition is right, we will have here a bond cleavage in between our chlorine and fluorine, which is actually a homolytic bond cleavage in which we will have CH4, that is not CH3, that is CH4, plus 2 add electron or free radical chlorine. In that sense, that free radical is actually very active. Therefore, it will be looking for a single pair of electron, and due to that single pair of electron, we will have here our CH3 that is actually also a free radical, and our hydrogen, which has an add electron pair also, as you may have remember. Add electron, not pair, and our two chlorine free radicals. Therefore, we will have here CH3Cl plus our HCl. Okay? So that is our types of reagent. So let me just check our time. So I have been recording for 40 minutes already. So in that class, I will be ending this lecture for now, and I will continue the last part of the lecture in another short video. Bye.